Hello, Niaz Mohammed is here again with environmental microbiology and public health and environmental biotechnology. We are talking about bioremediation, and bioremediation was a technique to use of the microorganism and other living organisms to remove the pollutants from the environment. As we talked in our previous lecture in detail, and today we have to talk about the air sparging. It is also a suitable technique to reduce the concentration of pollutant in environment. So here we can see it is the air sparging technique. Suppose any pollutant is present in this zone. Okay, what we have to do? We have to inject air. We have to make a hole to the site where contaminant is present, where pollutant is present inside of the soil. We have to make a well. We have to make a bore to that place, and we have to lead to that place through a pipe, and what we will do through air compressor, we will inject air. What will be due to pressure when we are inject air, it will spread through soil pores, and it will carry pollutant toward this side and toward this side. So what will happen? The concentration of pollutant will be reduced over here, because through soil pores with air, pollutant will travel to these sites. Number one. And second, what will be here? If you will think a little bit, air in air there are different gases. Those will oxidize the pollutant. Some pollutant will react with the soil minerals and soil particles and the soil sediments. Some content of the pollutant will react with air molecules, air gases. So gradually the active component of pollutant will be lesser and lesser gradually. And another phenomenon, third, pollutant in presence of air, it will convert into vapor. Its density will be light and it will move upward through pores and will diffuse with other gases. And molecules also will come to this water table. Gas flow in saturated zones, it will take here. Gas flow in wedo zones also will take. And from here we can monitor gas flow, extraction flow, soil gas to discharge or treatment if required. We can take pollutant from here, from monitoring well, and we can check the concentration of pollutant in this place. So air sparging is also a technique to reduce the pollutant, to treat the pollutant, and the three possible ways we have discussed over here. First one, it air molecules and gases which are present in air, especially oxygen, that will react with different components of the uh, toxin pollutant. Secondly, due to distribution, concentration of pollutant will reduce because the molecules of pollutant will react with soil sediment, soil particles, and with other things. Third, the molecules in pollutant which are present and are able to be vaporized, they will form vapors and will move to the upper side. So gradually, in due to this all technique, at the point of the pollution, concentration of pollutant will reduce, and it will convert into less toxic forms or it will disseminate. So concentration will reduce. Due to less concentration, its toxic effect can be lesser and lesser. So this technique by which we can reduce the pollutant concentration on the site of the accident or site of the spill is called air, air sparging. But compared to bioremediation, this is a little bit expensive. One more mechanism also can be if microbes are present over here, those will be aerobic and those can react with pollutant and decompose pollutant into less harmful or less toxic form. So by this air sparging technique, we can reduce the concentration of pollutant in the spilled site, in accidental site where pollutant is present. So we can see the next one. This is in situ bioremediation. In our previous talk, we discussed in detail that inside situ bioremediation is the remediation of, is the biodegradation of pollutant at the place where pollution is present. Where pollutant is present, we have to treat the pollutant at the site where pollutant is present. That is called in situ bioremediation. Suppose in river, if we are looking that sediment is contaminated with PCBs, soil sediment. So we have to treat the pollutants over there in sediment sites because the whole sediment from river we cannot transfer it from one place to another place for treatment. So it is possible, it is difficult. Therefore, we have to make a strategy to treat the pollutant at this site. So what we can do? We can make wells up to the bottom and we can add different type of microorganism and treatment strategies to degrade this pollutant. If anaerobic treatment is required, we can put certain microbial strains which can work, which can decompose, which can degrade pollutant in anaerobic condition. If it works in aerobic condition, so we have to add aerobic microbial populations, that we have to increase the oxygen concentration at sediment site to remove, to degrade the pollutant at this place. So here we can see because sediment is maybe present in lakes, in oceans, in rivers, and in ponds. And pollutants from its surrounding are going to the bottom of the pond, lake, or water reservoir. So mostly the condition is partially anaerobic condition because due to presence of due to presence of water layer and mud on surface of the pollutant, it not allows for the entrance of air to create aerobic environment over there. So mostly we have to try that partially anaerobic or partially aerobic, facultative aerobic, we have to introduce to that place to treat the pollutant over there. Secondly, if the pollutant may be degraded by aerobic condition, so we have to make certain designs. We have to make certain designs that air will go to this site and it will create aerobic environment over there to decompose the pollutant with microorganisms. If anaerobic condition is there, okay, we have to uh, arrive the anaerobic microorganism to the site of the contaminated place, and we have to seal and we have to create anaerobic environment to facilitate the growth of the anaerobic environment. So with passage of time, what will be aerobic or anaerobic microbial population, which has been facilitated by providing the condition they will decompose that pollutant at that site, and gradually its concentration will be less and less. Biostimulation, it is another technique to decompose, to degrade the pollutants in environment. That may be ocean, that may be river, that may be soil where pollution will go, and we want to remediate, we want to remove that pollutant from that particular site. Therefore, we are using most suitable technique to remove that pollutant. Air, if air sparging technique is suitable, we have to use air sparging technique. If we have to use anaerobic technique, anaerobic technique is suitable, we have to use anaerobic technique. Here we can see in this diagram, just we want to show that suppose anaerobic tank is leaking over there, and oil or pollutant is going into the soil. Some of the pollutant, some components of the pollutant will be volatile. Volatilization will take place because in almost most of the pollutants and majority of the pollutants they have different components, and most of the components are volatilizing. Volatile components are there. So at first step, from whenever it will spill into the environment, the most of the portion will be volatile, and this volatilization will take. What will be the remaining? Remaining will go into the soil, and it will react with different components of the soil environment. What will be? Suppose some will mixing will take place. Some things from soil will go into the pollutant, and some things from pollutant will go into the soil. So what will be? Its concentration will be reduced. Aerobic uncontaminated groundwater and aerobic margin mixing also will take place. So aerobic uncontaminated water also will reduce its concentration by facilitating aerobic microbial population to decompose this pollutant. And some inside will be anaerobic, where some anaerobic microbial populations which are present in this zone, they will decompose anaerobic core of pollutant. And some will be on surface where oxygen can reach, where oxygen can access. Oxygen will go into the pollutant and will react with pollutant, will reduce its concentration by making another compounds. And some oil components will go into the oxygen, they will be oxidized, and the pollutant nature will be changed. Aerobic unsaturated zones also will facilitate the aerobic microbial population to uh, decompose that water. So actually, what we are doing in this, we are facilitating the existing microbial population to decompose that pollutant. That is called biostimulation. Stimulate the existing compounds, existing microbes to decompose the pollutant in soil is called biostimulation. And this type of scenario takes place. Stimulated microbial populations are reacting. Aerobic microbial population is stimulated due to presence of oxygen that will react with this pollutant and decompose it. As it is anaerobic microbial population will be stimulated and they will decompose this pollutant anaerobically. So from the all over this from all sides, microbial populations, according to their potential, they will react with pollutant and will reduce its concentration. Okay. Biostimulation, how we can stimulate the existing microbial population, because in natural scenario we have seen this, it is going on, but we have to stimulate the microbial population, that the microbial population which is present normally over there, we have to do something that they will be activated to decompose that pollutant. So what is the suitable strategy? What we are doing, we are using pump, and we are adding nutrients and oxygen mixing unit. Okay, then we will mix that and we will inject it to here. We will inject up to that site aerated nutrient rich water. We will inject it to this zone of contamination, infiltration pit and soil surface. So we have injected nutrients plus oxygen. What will be due to this over here? Due to nutrients and due to oxygen, existing microbial aerobic populations will be activated. Their population will be increased. If population will be increased, their potential will be increased. They will need more and more nutrient, and due to higher microbial population, they need more food, so they will produce more metabolites and enzymes, and they will decompose this contaminant. Gradually, what will be the concentration of this pollutant will reduce, and it will move through aquifer, and the concentration of uh, that pollutant will reduce. So what is the most technique in biostimulation? Just we are stimulating the existing microbial population by providing nutrients and oxygen to the microbial population. When we are providing nutrition and oxygen to microbial population, the number of microbial population will increase, and increased microbial population will attack on pollutant, and the pollutant will be decomposed fastly and converted into its simplest form or elemental form. And from here we can check its concentration. Okay, how much and which type of pollutant is remaining, and how much is its concentration. And from again we can check here what will be whenever we are stimulating microbial population here, they will react with this pollutant, pollution concentration will be reduced. We will take samples from here, and we can check its concentration is reduced or not. Similarly, over here we can see in biostimulation we are using nitrates, phosphates, hydrogen peroxide to that side zone of H2O influences. So what will be zone of O2 influences? It will reduce the zone of contaminant, zone of nutrient influence. Once from one side, zone of nutrient, which increase the microbial population will reduce. From another side, this zone will reduce. Now we can see that concentration of pollutant is reduced. It is lesser now. It is negligible now. So this is called. So understand, please, what is biostimulation? Biostimulation means stimulation of existing microorganism to decompose the pollutant. And how we are stimulating the microbial communities? We are providing nutrients and oxygen to activate the existing microbial population for remediation of existing pollutant. This is another technique. It is called a bioreactor. In this bioreactor, just we are putting bioreactor over here. It will rotate, and the pollutant will be volatilized, and there will be a time Microbial populations also will activate. They will be mixed with pollutant, and gradually they will reduce the concentration of pollutant in this uh, reactor. So what we are doing, drive shift parallel to flow. Okay, in flint, from here we are injecting the pollutant. It will rotate in this uh, rotations in this drum, and at last its concentration will be reduced, and we are bringing it out. And now here we will check the concentration of pollutant has been completely reduced. So up to here it is okay, and you must have to understand this bioremediation technique for the treatment of the pollutants. We are adopting most suitable and most accessible technique for the treatment of the pollutant, and it depends on the officer of that site. He will decide which type of strategy and technique can be used for the treatment of this site. And further details, for further details, you can go in through book, through literature, and through research articles. And any environmental microbiology book you can take from library, or you can take soft copy from internet, and you can read it. So I will say thank you and welcome to you. Have a nice day.